Hi everyone. This week we continue our look at assembly, and this coming week I'm hoping that you will be able to download and install the IDA Pro Classroom Edition, and I will upload instructions to do so. But I just wanted everyone to get more comfortable with assembly because assembly literally is the backbone of malware reverse engineering. So this is a website called x86-64 Playground, and you don't have to have the x86-64 compiler. I am using this on my ARM64 MacBook, so we're doing okay. We're fine. So let me just what we can do here is just delete this area right here. Let me do this now, and we're just deleting this. And what we're going to do is we're going to make sure that, see how it says FASM? We want to go to GNU, and then we want to go to File, see this, and then we want to go to Load Example and just click on syscall new as, and there we go. Now we don't care about this. All we care is to get the proper headers. Now the headers are located on lines 5 through 7, so just these 4 lines is what we need, and then we can just delete this. Okay, we're going to delete this. And then, frankly, we can even delete these. These are comments, semicolon, pound sign. So, like I said, these are comments, and we can just delete those. And let me just delete this line right here. So, we have here the singular lines of disassembly right here. And we have our registers listed on this section of the web page. And what we can do, we can just scooch this over. Let's just sorry, I'm just trying to grab the arrow just to move it over so we can grab some more real estate right here. Okay, so speaking of the move command, so really this is just about using basic assembly commands. In this week, we're actually going to interact with the commands, which is interesting because prior to this, we were creating a C program, and then we would compile it, and then we would go through a disassembly process which would show the assembly commands making up the executable, right? But now we're going to mess with the basic assembly commands in of ourselves, and this is important because I kept showing you those assembly videos, right? And it's like you really need hands-on. So let's take a look at, as I said, these are our disassembly lines, okay? And these are, you could almost call these descriptors, all right? And these are our registers, RAX, RBX, RCX. Now there's two kinds of registers. There's a registers we can put our hands on, and also there's the main registers, which are RAX, RBX, RCX, and RDX. And then there's the secondary registers that were added later on, like RSI, RDI, and then came R8, R9, R10, R11, all the way through R15. And however, there's a couple registers that we want to keep our hands off of, and that would be RSP, RBP, and RIP. So those are stack pointers. Okay, so we want to just avoid those for now. So we want to do, and we'll just demonstrate, like, for example, the move command. So what we'll do is we'll move, for example, we'll move into RAX the value of 1, and we'll press enter just to move it along. Now, there's no change here. There's no change in disassembly, and there's no change in our registers because we have to compile and then continue. So we're going to press the compile button, okay? And as we can see, under start, we do have the disassembly command move into RAX the value of 1. Now, here is REX, and the register is still 0. So what's going on? We have to press continue. And once we press continue, we see now the value of 1 has been added to REX. Now you can see here it says program terminated with exit 139 due to signal seg v invalid memory reference, because there's no end. It reached the end here. Okay, so that's what the error. So we can just ignore that right now. Okay, we can do this again. We can move another value into REX. We can move the value of, say, 2. Okay, again, we can compile. Now we have the second line of code right here. Move REX 2. Now there is nothing in the registers yet, so we have to press continue. And now into REX, we have now the value of 2. Okay, now we can add REX the value of 2, and then we can compile, continue. Okay, now we initially added, we initially said it was 2, then we added 2, and now the REX value is 4. Now it is waiting, almost like it's waiting for the next command, hence the error right here. And this is where the pointers, here is the main pointer, the register pointer, and it's pointing to the value of 401012, and that is this value right here. So wherever this ends, this is where it's going to be pointed to. Okay, so let's go ahead and add, let's move a value into RBX. Let's move the value 8. Let's compile it and continue. So now RBX has the value of 8, and here it is in disassembly. We can also subtract, or we can, well, let's do add, and actually the value in RAX is 4. So let's add into RBX the value of RAX. Okay, and let's go to compile, continue. Now notice we have RBX is now the value of C, and that's because we're dealing with hexadecimal. So we had the value of 4, and we moved the value of 8 into RBX, and then we added into 8 the value of REX, which is 4. So 8 plus 4 is 12. Hence, RBX is listed as C because C is 12 in hexadecimal. Okay, so hexadecimal is 0 through 9. And then once we hit 10, because hexadecimal really is a way for us to understand the zeros and ones, understanding the binary format. Okay, so 0 through 9 is just 0 through 9. And then once we hit 10, the next character in hexadecimal is A. 11 is B, and then 12, of course, is C. Okay, and if we add into RBX the value of 1, we would get D, because that would be the next number. Excuse me. Now, what we can do is we can now subtract. Okay, we could do sub, and then from, let's say, the value of REX is 4, so we can sub from REX the value of 2, compile, continue, and then now from 4 we subtract, from REX we subtract, which was 4, we subtracted 2, now the value of REX is 2. Now, interestingly enough, okay, we can also increase. we can also increment. All right, so we can do increment and